The ratio test is an algebra lover's dream. It is absolutely amazing. It's glorious. I love it. You get to cancel and factor to your heart's content. Now, to put this in context, we have covered a lot of different series convergence tests. We have talked about geometric series, and we can tell when they converge or diverge. We've talked about integral test. We've talked about p-series, direct comparison, limit comparison. We also talked about the nth term test for divergence. I'm waving my ink pen as I talk about these. I just wanted to put this in context because this is yet another way to determine if a series converges or diverges. Now, that word right there may not mean anything to you yet, but it will within the next couple lessons. Very briefly, let me tell you what this is going to mean. A series converges absolutely if it converges for both its positive series and its alternating series. Now, out of context, that doesn't make much sense because you haven't encountered alternating series yet. You will in the very next lesson. But before we get there, let me just tell you that I could have a series like this, 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus, and you can get the drift, this is 1 over n squared, right? This is going to converge. And we would also say that 1 over 1 minus 1/4 plus 1/9 minus 1/16 plus 1/25 minus 1/36, you know where this is going. This is also going to converge. So we would say that the series converges absolutely because it converges whether you're dealing with only positives or positives and negatives, okay? So that's what that word is going to mean. It is a little bit out of context right now, but I just wanted you to see that and know it. It's going to happen later. All right, here goes. We're going to let the sum from 1 to infinity of a sub n be a series with non-zero terms, so can't have zero terms in there, and because you'd be dividing by 0, right? That's just tragic. Don't do that. I tried it once. Ugh, bad memories. If the limit as n approaches infinity of a sub n plus 1. Whoa, okay, what's that? Just to be clear, just to provide some context, a sub n plus 1 is the next term. That is what that means. So I need the next term. So let's go ahead and kind of get started. We're going to divide this by this, and if we get a number less than 1, then the series will converge absolutely. If we get a limit that's greater than 1 or infinity, which of course is greater than 1, then we have a divergent series. And then if it equals 1, then we really wasted our time. Depends on the context of what we're doing, okay? So we're going to determine the convergence or divergence of each of these, and we're going to start with this one right here, and it actually starts at 0. So the next term is going to be, well, what happens after n? Oh, no, not O, n plus 1. So we need the limit as n approaches infinity of, okay, next term. The next term after n is n plus 1, so 3 to the n plus 1. Over n plus 1 plus 1. Now, that's way too much, and I'm writing way too much, but n plus 2. You can get my drift on that one. So that is going to go over this. This is the nth term. This is the n plus 1th term. And we're going to have that right there. There we go. And it's going to equal the limit as n approaches infinity of. Now, here comes the fun algebra stuff. We have 3 to the n plus 1, which is really 3 to the n times 3 to the 1, divided by n plus 1 plus 1. And so n plus 2 factorial. I'm going to go ahead and call it n plus 2 times n plus 1 factorial, because it's the same thing, right? N plus 2 factorial is n plus 2 times n plus 1 times n times the next one times the next one. And we're going to divide by, let's flip this thing over because I wrote multiplication, n plus 1 factorial, yes, they cancel, and 3 to the n. Told you this stuff was fun. Let's absolute value this thing. Now, here's where this is going. I want to know if this is going to be equal to 1. If it is, then I will frown and be like, that got me nowhere. If I get a number greater than 1, like infinity, then I will say that the series diverges. If I get a number less than 1, then the series converges absolutely, which is something that will happen later. It converges. That's all we need to know for this lesson, but absolutely will come in handy later when we're dealing with alternating series, like I said. So let's keep driving this train. Let's cancel in grain. I wanted it to rhyme with train. I'm going to cancel in grain. Driving this train. all over this plane. Plain, like you're riding across the open plain. You're not like in a plane and a train at the same time. That would just be weird. We have 3 over n plus 2. What you gonna do? I don't know why I'm singing it like a country song. All right, so we have the limit as n approaches infinity of 3 over n plus 2. The denominator is going to increase without bound. Therefore, this is less than 1. This is equal to 0. Let's throw an extra thing in. If you want to put that, that's fine. I'm gonna go a little crazy on you here. Not too crazy. This is equal to 0, which is less than 1. Therefore, finish that sentence. Therefore, the original series they gave us, that we did not really modify other than we went to the next term, n over n plus 1 factorial, it's going to, at less than 1, it must converge. And I'm going to go ahead and say it converges absolutely. Converges absolutely.